I'm going to talk about the Ruby after 25 years. And this is the stripped down version of the keynote speak in the Ruby Elixir Conf in Taiwan this March. This year, we celebrated the 25th anniversary of Ruby. The Ruby was born in 1993, February 24th, 1993. This is the day I picked the name Ruby. It's not the date I released it, or it's not the day I started coding it. I just named it Ruby on that day. So in Wikipedia, for the programming languages, it records the release date of the language, and which is, it doesn't work. Oops. It is the December 21st in 1995. So the Ruby project was started in 93, and then the release in 95. It is actually it is as old as Java. The Java project was started, which is the original name is Oak, and the project was started in 93, and the first white paper of the Java programming language was released in 95. So the Ruby is actually as old as Java. It's the same age. So what's wrong with it? So she has just turned 25. So the 25 years ago, we wanted to name it after Joel, just because we have the programming language named Perl. So yeah, and I used a little bit of Perl and mostly shell scripts. So I wanted to create my own programming language, and the language compiled to the native code is quite difficult. You have the knowledge of the platform as well as the knowledge of the native code, so which differs from CPU to CPU, and then having overcoming that obstacle, the beating, competing to the C compiler is quite difficult. So I just gave up that path. So I just created some kind of interpreted programming language. So that I created scripting language, because Shell and Perl scripting languages are the second most used programming language I used in 25 years ago. And the Perl was pretty famous for scripting language. Remember that 23, we didn't have the Perl 5, so it doesn't have any object-oriented programming feature. So I wanted the better programming language than Perl. Yeah, we have the rumor about the Perl 5, which should have the object-oriented feature. But the object-oriented feature of the Perl programming language is a little bit awkward, as I say. So I created the object-oriented scripting language. So we wanted to name it after Joel. And then we had two candidates, the Ruby or Coral. But Coral was longer in one character. It should be the name of the name of the program, so that you have to type every time. So that the only one character difference make tons of times of the type in combine. So the Ruby is shorter and more beautiful. So we picked Ruby. Ruby is shorter and more beautiful, and then Ruby was more precious. Afterwards, we found out very interesting coincidences. The birthstones, the Perl is the birthstone of June, and the Ruby is the birthstone of July. And you might know the font names the real font, physical font, has the name according to their size. So the 5-point font has the name Pearl, and the 5.5 point, the next bigger font, has the name Ruby. So it is quite sufficient name for the next Pearl. The next Pearl was our primary goal at the very early stage of Ruby. I tried to make Ruby, the language, as useful as Perl and as strong as Perl. And to be honest, we went too far. Present day, we are not no next Perl. It's next Perl is Perl 6. In fact, it's next to Python, or it's following Python maybe in some aspect. And it is quite difficult to imagine the future. So now, 25 years ago, it is pretty difficult to imagine the present day. Like Ruby is used worldwide. No way. So the prediction of the future is always hard. So did I foresee the current popularity? Definitely no. So that there is tons of programming language out there in the internet. So that we have, I don't know, maybe tens of thousands of programming languages out there, and then most of them they're very unpopular. Very few people know about the language, and they gradually disappear in the history of the internet. So, but in some coincidences or maybe some accidents made Ruby very popular. The predicting the future is always hard, difficult for anybody. So it's okay to be irresponsible about talking about the future. So it's okay. I'm going to talk about the Ruby after 25 years, okay, about the future. So the trend now is the scalability. The 25 years ago, the computer was pretty weak. I use the Unix workstation, which is very, very expensive, but still the power of the computer is pretty much weak. Maybe 100 times weaker than my laptop. It's quite, the first Unix workstation I worked with, I developed Ruby 25 years ago. It was the CPU was the Motorola 68K, and the memory was, I don't remember, a few megs of memory, and then the hard drive was 180 megabytes of the hard drive. It is nothing compared to the present days. Well, everything getting bigger. So we have the terabytes of memory, the terabytes of the storage in my laptop, and in the server we have, I don't know, the petabytes of the storage the collectively in the data center, and the memory was maybe one host had the 64 gigs of memory. It's far bigger than my hard drive back then. So everything get bigger. The data size is bigger, traffic size is bigger, program size become bigger, and the team size get bigger. So we have to fight with these sizes. So this is how we work on Ruby 3, the next major release. It's kind of our fight against the future. We have three major goals: the performance, concurrency, and the static analysis. The performance is pretty much important for the language architecture. Of course, Ruby is slow compared to, say, C++ or Java, because it's interpreted. It's run on top of the virtual machine. But no one complains about the faster Ruby. So that we enjoy the productivity of Ruby and the succinctness of programs. But still, if Ruby runs as fast as, say, Java, that's okay. So if Ruby runs faster, we process more data, or we process more traffic, so that we can fight with these sizes. And then these days, the single core, the performance of the single core would not be improved because of the limitation of the Moore's law, because the circuit in our CPU is so teeny, so that if we design, if the Intel company designed wrongly, so that the chip will be burned. Too many heat there, so that they have to put the many cores in the chip, so that means that we don't have the faster core, but instead we have many cores in the chip, so that we have to utilize the concurrency to accomplish the performance. So these cores, utilizing these many cores, we can handle more traffics. And then by providing the way to static analysis of the program, so that we can fight against the size of the program. The size of the team and the size of the software is getting bigger and bigger, so that to fight against these sizes, that we have to provide better way to find bugs and the tests. So the performance and concurrency in the static analysis is the three major key to the Ruby 3. So by performance, we have the project named Ruby 3x3. So that means that Ruby 3.0 will be 3 times faster than Ruby 2.0. Let me explain a little bit about that. So that we are not going to have the big jump toward the Ruby 2x and to Ruby 3.0. So that we are adding new features to Ruby 2x. Like we have added a new garbage collector to Ruby 2.2, or maybe we added some kind of the incremental garbage collector in Ruby 2.4, or we had added some kind of the JIT compiler to Ruby 2.6 in the current version, so that we are going to release this Ruby 2.6 in this coming December. So that means that you will enjoy the JIT compiler next year in it. Or you can try it right now by downloading the trunk, the bleeding edge version. So the performance will be improved every year. So that compared to Ruby 2.0, Ruby 3.5, the current version, the recent version, runs, 20-30% faster. And then consumes many times less memory. So that we have improved that much. So that we want to measure this kind of improvement into this kind of Ruby 3x3. So it's not easy, but we need the difficult goal. Like the President Kennedy in the 1963, so that he made some kind of announcement to bring human being to the moon. And then at that time of the year 63, it is nearly impossible. But he declared, we go to the moon. We go to the moon. Because it's not easy, it's easy, but it's difficult. And it's a huge technical challenge. But by having that kind of goal, in July 1996, the 3 people went to the moon and standing, walking on the moon. 16. Did I say 69? 96? I'm sorry. 69. 69. 69. July 69. Oh, yeah. I remember I watched that on my TV. And then most of you haven't been born. Anyway, this kind of goal is Ruby 3x3. And by having goal, miracle happens. And then last year, a guy named Vladimir Makarov, who is from Canada, who was born in Russia, and then yeah, he is employee of the Red Hat, and he's in charge of the development of the GCC for the last 20 years. And he's the very expert, nearly genius of the compilers. And then in RubyKai 2017 last year, and he presented about the MJET, which comes the RTL, if it stands for the Register Transfer Language, which is the technology behind the part of the GCC, and MJET, which is that stands for the method jet. So that it is kind of silly though. It is a JET compiler. That means the MJET generates the C code into the file corresponding to the Ruby programs, Ruby methods. Then it kicks GCC or C clan to compile these generated C files, then load those compiled functions by the DL open dynamic loading, then run it as a native code. It's kind of a silly idea, and he implemented that, and it did run fast. So that he implemented the just-in-time compiler using GCC in the realistic way. It was, yeah. Actually, I was jokingly discuss about this kind of the approach, but we just gave up. It's kind of silly, but he was serious and he implemented that. I was so impressed. It's compiled by GCC, but one drawback is he implemented new virtual machine, whole new virtual machine. RTL itself is assigned on the register-based byte code. So that he implemented the virtual machine and its compiler. And the big problem is the big jump. So that replacing the virtual machine and the compiler at the same time is too huge. So that it is quite difficult to debug the things. So that it is, his MJET runs some small Ruby's programs very quick, pretty fast, but it couldn't compile the, say, Rails programs. The Rails application is huge as a whole, so that it's too big. So that it was hard to be stable, and it was hard to keep compatibility. So the other guy, Takashi Kokubun, implemented the MJET, which is the replacing RTL by the current virtual machine bytecode. So it's not fast, it's workable. So the currently he's working on improving that, and we have tons of rooms to improve the performance. So that next Christmas you are going to have the Ruby 2.6, which comes with the JIT compiler. You don't expect the performance yet, but we have tons of rooms to improve it. So that in the future we have a lot of chance to improve the performance. Then, so that, Brad, who originally developed MJET, so that he, the part of his work, MJET part, the compiler framework, JIT compiler framework was taken, but we have to give up his very important RTL RTL part. So he tried again in this Ruby conference this year. He came back and which one? Okay, I made a mistake in the slide. Okay, let me see. We will see the JIT in Ruby 2.6 next Christmas, and you can try it with the --JIT option, so that you download the trunk version. So you put the --JIT, so that the JIT compiler will work. And a very simple software the naive loops runs pretty fast, but in a complex program like Rails application will it runs somehow. And and the Brad came again, tried again. RubyKai 2018 comes with the new technology like the MIL, which stands for peace in Russian, and then that means lightweight JIT. So that in the very complicated language implementation like the V8 or maybe the Firefox JavaScript implementation, it has the many layer of JIT. So that he has the lightweight JIT, and then the problem with the MJIT is it is very heavy to compile everything by the invoking C compiler. So that we try to reduce the burden, but it's still heavy compared to the built-in the JIT compiler. But the MIL is very lightweight JIT compiler. And then it only supports the x86 and ARM, but it is quite lightweight, so that you can build M. And it is not fully optimized, but it runs anyway. So that and the compile time is 10 times faster than MJIT. So that maybe we can have MIL in the future version of Ruby to implement the more lightweight, more faster Ruby. So JIT is not panacea. It improves the CPU intensive task, but if the bottleneck is not CPU, it doesn't help it, the performance at all. So that don't expect too much. So that I don't say that every Ruby program will run very fast in using JIT, but CPU intensive tasks like loops or maybe some kind of text processing or things will be very fast. Well, maybe if the bottleneck is the database connection or maybe network, it won't help. Okay, concurrency. Yeah, as I said, concurrency will fight against the traffic size, and we have the multi-core and many-core these days, and the multitasking. The multitasking is over-evaluated. For example, the Node.js the claim to be very fast, but it's single-threaded. So we might not need the real multi-threading in many cases, but at least we have some kind of the CTU intensive multitasking. So that in that way, so the real multitasking will help. So we have a language named Elixir and Erlang, which has the very concurrent virtual machine, and or maybe we can have the multi-process, put up everything, every multitasking into the operating system like the Linux or maybe the Windows or something. So that these kernels can easily handle the multiprocessing. So the bottleneck of Ruby programming language is GIL, which stands for the Giant Interpreter Block. So which is the Ruby basically runs one thread at a time because of the safetyness. Because of the safetyness. the thread shares memory, the thread shares object and the status. So that if multi-threads are accessing the same object at the same time, it's quite difficult to keep the consistency. So that to keep the safety, so that we need to have the giant interpreter lock. So that it is quite easy to remove this giant interpreter lock by modifying the few lines of code of Ruby virtual machine, but your software will probably crash. the Zero is for your safety. It's safer, but it's slower. So we have two ideas. One is the auto fiber, as Node.js did that, so that we have the for IO intensive works. So that we have the very quick context switching is required. So the fiber is much lighter than threads, and it's much easier to understand. So the auto fiber is the I/O context switching by I/O, and it's still the fiber. So its overhead is much lighter. For the CPU intensive tasks, we are going to implement the guild. The guild is the little bit different abstract of concurrency, and I'm not going to tell you about the detail, but the Koichi Sasada, who is the VM guy, is in charge of it, and he's diligently working on it. So we can probably, by using this kind of the higher level abstraction, we can go even further. Say cloud-based FaaS, which stands for the function as a service things. So that by using this kind of the guild stuff, you can build up the very efficient Ruby function as a service. So or maybe highly distributed tasks. Static analysis. It's almost all of the time. So the Ruby is optimized to the small teams, concise, abstract, flexible. But after Ruby on Rails, the software is getting bigger and bigger. Dramatically, the Ruby on Rails itself is dramatically easy to development by providing web abstraction, but abstract view of web development. But abstraction is the key. But as a team get bigger, a code get bigger. It'll be harder to maintain. Then the people require static typing, like to JavaScript. People approach the coming rays of TypeScript or something like that. But I don't like that because the static typing is not dry. So that if a program works with the types, so that we should not be able to omit. We should be able to omit them. I don't know this and things, but forget about that. So that the types is the key, but I don't want to write something on the type declaration things. It's redundant. So the people named the guy named Sotoro Matsumoto. And he challenged static type inference in Ruby in his PhD paper, but he proved it's nearly impossible. After his graduation, he tried twice and failed. So the type inference, traditional type inference does not work for Ruby. So his new challenge is named Steep, which does not infer types most of the cases, but Steep requires type description files, like a TypeScript does. So imagine .d.ts file involved TypeScript, then Steep 6 type integrative. There are two ways to provide type description. So the type description file and the comments. I'm not fully satisfied with it. It's still redundant. But the future is also, providing these kind of the type description file, I think we can extract this kind of type description from YARN documentation, or maybe type inferences, or the runtime type aggregation, or the abstraction interpretation, which we call it AI. Yeah, Ruby generate the type information from AI. Yeah, sounds nice. Yeah, runtime type aggregation means that you write tests, right? Yeah, and then you run tests, right? So that by running a test, you have the type information of the method of the class, and then once we run the test correctly, after gathering these kind of type information, so you can generate this type information to the type description files. So runtime type aggregation, and then or maybe if you have some free running software, by virtually tracing the runtime call path, so that you can gather the type information, basically this which is we call the abstract interpretation. So by by evaluating this abstract interpretation, you can gather this kind of type information. That from that kind of type information, you can generate the type description. Once you have type description file for every method, every class, so that you can have the static type check using the technology like STIP. So that means without writing any type annotation to your code, so you can statically check the type of your software. That would be nice. So at the beginning of the Ruby 3 project, this is kind of like the dream, a kind of impossible dream. But having research, having experiments, so now we have these great things, including JIT compiler, including the higher abstraction, concurrency abstraction, and this type inferencing things are the type. We call it type guessing, because by using the term type inferences, the type theory people will be get mad. So that we call it type guessing. Anyway, this kind of static analysis is nearly possible in the future, maybe a year or two. That would be wonderful. So we will have the Ruby 3. The performance will be improved by using MJIT and other technologies, and the concurrency in Guild and Artfiber, and the static type analysis using the STIP and the software analysis things. So that would be great. So we will have Ruby 3. It will be the continuous evolution we will have. So remember. So we will continue the incremental development. So that we are adding feature by year. Ruby 2.5, 2.6, 2.7. So that we are not going to have some kind of big gap between the Ruby 2 and Ruby 3. So we are not going to have that kind of gap between Ruby 1.8 and 1.9 or Python 2 or Python 3. We are not going to have that kind of big gap. So that just we keep improving the language, the value in the keeping the compatibility, so that we are not going to have any that kind of compatibility hell again. So that it's kind of the division of the community. So that some people keep using the old version, some people keep using new version. So that the half of the community stay old version. Giving up the new technology, new performance improvement, and new functionality or anything. So that kind of things, we are not going to see that kind of situation never again. So that it's out of time to say. So our goal is help us accomplish great things. So with simple Ruby code, and simpler, safer, and more enjoyable. So that 10 to 7 years ago, Ruby was hot. Everyone everyone was excited about the new technology named Ruby. It was not very new though. But anyway, 10 to 7 years ago, everyone was excited about new technologies. But these days, no one excited about hearing about Ruby. Okay, Ruby, I know Ruby. Yeah, but the Swift is new. Or Rust is great. Yeah, that's true. But still, we are keeping improving the language. We are trying to keep Ruby great. So Ruby is great, I believe. Yeah, you agreed? Yeah, I'm forcing you. And Ruby is great in a way. It's not hard, but it's great. And we try to keep the Ruby great. Keep Ruby great, and improve it. So applicable to not only web, or maybe to the DevOps things, or maybe to the the embedded field, or maybe in some kind of general purpose programming language, or even to the research computing or the data science things. I know there are the more popular language in those fields, but by keeping compatibility, by keeping moving forward, so that Ruby can be applied everywhere. So that unless other factor happens, so that I want Ruby to be your first option to the technology. So it's I spend too much time, I guess. So that okay. In Intel, only paranoid, the profile says only paranoid survives. I'd love to be a paranoid to survive. So the language comes and go. Like we had Fortran, we had COBOL, but these languages still survive. But no new programmer enjoy learning these languages because they're old. They're abandoned ancient programming language. I don't want Ruby become like that. So that we will do everything to survive, to keep providing values. So that so to make programming fun again. Okay, thank you.